Does anybody have a value for carbon yet? It's going to be 0.7? 0.4?
0.1.
Yeah, okay.
Or
0.1436. We'll go with that. And does anyone have a value for hydrogen? Anyone shout it out? I don't care. Shout it out.
0.2861.
0.2861. And how about the oxygen? That's going to be right around 6, isn't it? Or sorry about that. 0.06.
0.0477.
Okay. Now, what do we do at this point? Divided by the smallest. This is the piece that a lot of people forget that convert to moles. Now we divide by the smallest, which is 0.04787. And so we get carbon is going to end up being, pretty big number. 3, a little over 3. Or is it 3? 3. Hydrogen is going to be around 7. 6, not bad. And obviously the oxygen is 0. So there, we just calculated the empirical formula of, and I can't remember what it was. It wasn't ibuprofen, it was something. Epinephrine. Is that what it was?
Yeah.
Okay. Or adrenaline, I guess. All right. You know what? No, it wasn't. Wasn't this the ethyl butyrate? The pineapple smell? Because we were doing the combustion analysis. This is the pineapple stuff. Turns out, and this is going to be first, its molar mass in a separate experiment was determined to be around 160 grams per mole. So what will its molecular formula for the ethyl butyrate be? So what do we do from here? Yeah, we find out what the empirical formula mass is. So 3 carbons was around 36, plus a 6, 22, around 58-ish or so. So we take this and divide by the empirical formula mass, which is, anybody have the actual empirical formula mass? 58.03. Divide, we're going to come up with some. 0.09. Okay. Okay. It's not going to make that much of a difference. Really?
Yeah.
Okay, that's okay. Oh, I lied. I can't read this. Give me a second. I got to think what ethyl butyrate is. 2. Yeah, that's got to be 160. I'm just asking, did we start off with 2.78 grams of compound? Is this the question that we start? Okay. I wrote on here, and I can't. That's got to say 160. So what'd you guys get for your factor? 2.75? Okay, now, here's the deal. That molar mass was plus or minus 5 grams per mole. So if we got up to 165, that would probably get us into closer to 2.8 range or so, okay? Which we would then round to probably 3. That's a long ways off. If this on the AP exam, they wouldn't give you that far off. you would be much, much closer than that. But anyway, regardless, if we ended up rounding out to 3, it'd be C9, H18, and then O3. Okay, this is all stuff you've done before. You should be fairly comfortable with that. What I'd like to do is give you one more combustion analysis problem to try on your own without me doing anything with you. I don't think there's one in that book I want to use. I like Chang. You guys like Chang? Except I don't think he does. Oh, here we go. Here's a good one. So now we have a compound this time that is have you guys ever heard of leaded gasoline? Has that ever come? Okay, let me ask you this. When you guys buy gas, I'm sure you've seen a little sign that says unleaded. Most of you have probably observed that. And you just thought, okay, this is what I get because this is what's in the thing. We don't know why it says unleaded, but this is what I'm going to buy.
Exactly.
Right? Okay, and I get that. But back, again, as it turns out, I'm a little bit older than, well, most of your parents. They used to put lead in the gasoline. Okay, it's small, very, very small amounts. Okay, but what I don't know, has anyone ever messed with lead before? It's a fairly slippery metal. It's very smooth, very slippery. Kind of not a whole lot different than your graphite. And you guys have ever played with that before? It's just got, it's kind of slippery. Anyway, they used to put a compound called tetraethyl lead in gasoline. And what that did is kind of lubricated the engine parts that were subjected to a lot of friction and stuff. Worked out really well, except as far as the engine was concerned. But the problem was when you start burning gasoline in a very high energy environment, you start producing some lead compounds that was spewed out as exhaust and ended up where? All over the place in the environment and everything. And then you, of course, may be familiar with lead poisoning. Okay. So anyway, so now, we're spewing all this lead all over the environment and so on and so forth, and people are starting to get a little bit of lead poisoning here and there. So they started phasing out leaded gasolines. That caused the engines not to run the way they should run because they hadn't been made to those standards before. So they had to cost a fairly significant amount of money to redesign the engines so they could run on what we now call unleaded gasoline. However, they do still add a compound to help reduce the friction, and that is methyl tert-butyl ether. I'm not going to have you do that problem. We're going to do the tetraethyl lead compound problem. So here we go. So we're going to take a compound that contains carbon, hydrogen, and lead. The main reason I want to do this problem is to show you that it doesn't always have to be oxygen over here. It could be nitrogen, sulfur, lead, whatever. It doesn't even matter. Okay. We're going to combine that with some oxygen in, say, an engine compartment. We're going to produce carbon dioxide, some water, and some lead-containing compounds. Okay, it doesn't really matter what. Okay. In this particular question, the mass of the compound was 51.36 grams. This was in excess. Carbon dioxide was 55.90. And the the water was 28.61 grams. What we're trying to do is find ultimately the empirical formula for the compound. haven't noticed, it is very similar to the combustion analysis problem we just finished up. The only difference is instead of oxygen being here, we have lead here. No big deal. I'll just say ready, set, go. Now, Ashton, you probably haven't been flipped over on Canvas yet. You haven't probably even been on Canvas from the other side yet, right? What's that?
I just like my Canvas got this house I go.
Oh, okay. So you're familiar with the existence of this, or whatever. But I'm going to guess for this class you haven't been flipped over yet.
No.
So same thing with your guys' class. All those couple little lectures that we've done already, I videotaped those. You're probably aware of that. I dumped those onto the calendar on Canvas. You can access them from there. You're missing a couple of bits of information. This is probably an extension of what you guys did, and really for most of them it was possibly also an extension. Did any of you do a combustion analysis before the other day? A couple of you did? Okay. Yeah, I know you did a little bit. So this is kind of an extension of that empirical molecular formula thing that you learned back in regular chemistry. It's really not, just kind of hang tight for a little bit. I'll walk through the solution to it. Just follow along there, okay? And while you guys are doing that, I'm gonna get something for you. or two of you might be done, so I'm gonna start flying through this. Help me with some answers here if you get a chance. So we take our 55.90 grams of carbon dioxide, because we're trying to find the mass of carbon that came from here. And hopefully you guys went this route. Does anyone have a result for that? Shout it out if you do.
15.25.
And then 28.61 grams of water. We know there are 2.02 grams of hydrogen for every 18.02 grams of water. And you guys are comfortable where those came from, molar masses of those things. And anyone have a thing for that result? 3.21 grams of hydrogen. Now, to get our mass of lead, we take our total mass of compound, we subtract from that the masses of the individual elements that we've already determined, and I don't know, 33-ish. 32.89. Okay, so this is where we picked up today with the previous problem. Would you guys agree? And at this point, what do? Convert to moles, divide by the smallest. So 1.25-ish up here. 1.27. That comes out to really close to 3.2. 3.175. And the lead comes out to 7.14-ish. 0.15. 7.87. Divide by the smallest. 1.57. 15, 20. So H is around 20. Carbon's around. That's going to be 8-ish. 8. And obviously the lead is 1. Everyone hunky-dory on that? Felt pretty good with that? Okay. Combustion analysis is about all we really need to do. How much time do I have?
2 minutes. Maybe.
How many?
1 minute.
Like 1 minute.
Oh, that's it? Okay, tomorrow we're going to do